Hi friends, we would like to understand about the concept of hydrostatic pressure. So, let me first give the definition of hydrostatic pressure. It is pressure exerted by weight of a fluid at rest condition. Means the fluid is at rest condition and on account of its weight, whatever pressure is coming on a surface, that is called as the hydrostatic pressure. Let's understand this in more detail. So, suppose we have got a container like this, we can see from the diagram itself. Now, in this container, if we say that it is filled with liquid up to certain height. So let's say it is filled up to certain height h. So this fluid which is there inside the container is going to exert certain force on its base. So the entire weight of the fluid is acting on this particular base. So we can say the force acting on the base is nothing but the weight of the fluid. So here I can say the force F which is acting on the base is nothing but the weight of the fluid. Let's say weight is, we are denoting by W. Now, but weight is what friends? Weight is nothing but mass of the fluid into gravitational acceleration. Okay, and if I say the density of fluid is rho, so rho is a mass density, so rho is nothing but mass divided by volume of fluid, volume, that is V. So from here I can get the mass m will be nothing but mass density into volume, friends. And if you see this particular diagram, the volume of fluid is nothing but the area of base. Let's say area of base is A, friends, and the height is h. So from here I can easily find the expression of mass of fluid, that is rho into area of base into the height of fluid filled in the container or in the cylinder, right? So we got mass equal to rho into A into h. So from here the force due to the weight of the fluid is nothing but the m will be replaced by density, mass density into area of the base times height into g. So we have got a very important outcome, that is weight or the force acting on the base of the container is mass density into area of the base, that is area of the cross section or the base surface, h is the height of the liquid level and g is the gravitational acceleration. Now this force is going to exert a pressure on the surface, so that I will write down here. Therefore, the pressure or the hydrostatic pressure, we can say, acting on the base, right? Base of the container is given as, I can call it as small p, and that is nothing but the force divided by area. Force is due to weight divided by surface area, area of base, and if you know area of base is A, friends. So this you can simplify as the pressure will be equal to mass density over here, area of the base, height of liquid level, gravitational acceleration g divided by the area of base. In the numerator also we have got area of base, in the denominator also we got area of base. So from here a very important outcome will be there, that is pressure. This is also called as pressure intensity. Hydrostatic pressure intensity is given by mass density, you can see here. I'll write G first, gravitational acceleration times height of liquid level. So this is the expression for pressure intensity or pressure, which is called as hydrostatic pressure. So the pressure intensity, that is P, is given by rho g h. This is also called as hydrostatic pressure and it depends on h. So this h term is called as pressure head. Since hydrostatic pressure depends on the height of liquid level, so height itself represents the pressure, okay. So therefore this h is called as pressure head. So friends, we are discussing the concept of hydrostatic pressure. So friends, we have seen that if there is a container filled with a liquid of density of mass density rho up to the height h, so its weight is going to act on the base of the container like this. Okay, so this is going to cause a force on the base and this force will produce a pressure on the base which is called as hydrostatic pressure. So we have found that hydrostatic pressure intensity P is given as, so we have obtained the expression for hydrostatic pressure intensity and that is given by mass density into gravitational acceleration g and into height of liquid level. Okay, so it is very much clear from this particular expression that the pressure intensity depends on the height of the liquid column or fluid level. Okay, this height is called as head. So from here friends, we can conclude that the hydrostatic pressure intensity P depends on the height of the level of the liquid or the level of the fluid. So pressure intensity, that is P, depends on the height of liquid level or fluid level, we can say. that I'm calling as H. So this height of fluid level is referred as pressure head. It means we can also express the pressure intensity in terms of the height of liquid. So the pressure can be expressed in terms of height of liquid level. This is a very important outcome, friends, which is called as, and hence it is called as pressure head. It means height of the liquid level is called as pressure head. Very simple it is now. So if I want to say that what is pressure head, therefore pressure head is, it means H. Now from here if you see, we got P equal to rho g H. So if I want to find H, H will be P by rho g. So it is nothing but P divided by rho g. So pressure head is, H is nothing but P by rho g. So P is basically, what is it? The pressure what we have obtained, and then which fluid we are going to use. So we can say mass density of fluid times gravitational acceleration g. So friends, we can use the concept of pressure head to express a pressure in terms of height of certain liquid. Okay, so it means, suppose, so a very important note, friends, any pressure can be expressed by height of liquid level, height of a particular liquid level, or we can call a column. Okay, so H is nothing but, pressure head H is nothing but P by rho g. So friends, this is the expression of pressure head. So let's solve some simple examples in which we will express the given pressure in terms of height of particular fluid or particular liquid. So let's take one example here just to understand this. Okay, so we'll try to solve one problem in which we will express 200 Newton meters square in terms of pressure head of a water column. Means we are going to express in terms of water level, okay, height of water level, and B mercury column, means mercury liquid level. Okay, these are two possibilities we are using. So please remember, the density of water is 1000 kg per meter cube, while density of Hg, which is mercury, is 13,600 kg per meter cube. So we shall be using these two liquids to get the pressure head of 200 newtons per meter square. It means, so friends, we have got a pressure of 200 newton per meter square. So let's do it. So let's go for the solution, friends. So first I'll write down the pressure, the given pressure. Pressure P is 200 newtons per meter square. First part, pressure in terms of height of water level, height of water, that is the pressure head. This is the pressure head, we say, right? That I'm going to call as H, H2O. H2O stands for water, okay, and that is nothing but P divided by density of H2O water into gravitational acceleration. So if I do this part, friends, I'll be getting pressure head in terms of water will be 200 newtons per meter square divided by density of water is 1000 newtons per meter cube into G. G is 9.8, friends. I am going to take approximately value of J as 10 to make it simple. So it is, take G as 10 meters per second square. Just for simplicity, I have taken this. So divide by 10, friends. So if I simplify this whole thing, I will get, so two zeros are getting cancelled out here. So down we have two zeros. So 2 by 100. So that will be, friends, if I calculate 2 into 10 raised to minus 2 meters of water column. Okay, so water will be, so 200 newtons per meter square will be equivalent to the pressure head of water having height of 2 into 10 raised to minus 2 meter. Okay, so if I do it in centimeter, it means I can say it is 2 centimeters. Okay, so I can, in simple way, I can write down pressure head of water will be 2 centimeters. Now I'll take another part of it, that is second part, where I have to find out in terms of mercury column. Okay, so similarly I can find out pressure head in terms of mercury column, and that will be HG. Hg stands for mercury, friends. That is P divided by rho mercury into gravitational acceleration. And if I simplify this, that will turn out to be 200 newtons per meter square divided by the density is 13,600 into, so density is, friends, density of mercury is 13,600 and G I have taken 10. So if I simplify this again, here if you see, two zeros will be cancelled out here and here. So it is going to be 2 divided by 1360. So if you simplify this value will turn out to be 0.147 centimeters. So friends, you can see here the pressure head in terms of mercury is further small compared to pressure head in terms of water. Okay. We will see some more example as we go along to make our concept more clear about the pressure head and the pressure intensity. Okay. So pressure head is nothing but expressing the given pressure in terms of the height of certain liquid. Maybe water you can take, maybe mercury you can take, or whatever liquid is given to you, you can take that liquid or any kind of fluid. In terms of height of that fluid, we can express any pressure. So that is called as pressure head.